I'm going to talk about Hyperledger first, a little bit, because that is very important to situate or to say why URSA took flight and is important. Hyperledger is one of the few consortia to have multiple DLTs being incubated. If you look at other consortia, most of them have a single one. In Hyperledger, there's Fabric, of course, which everybody confuses with Hyperledger. They say when they say Hyperledger, they mean Hyperledger Fabric. So Fabric, which is got a lot of traction in the space in the enterprise blockchain space. Then you have Burrow, which is the I'm looking for this little device. They told me it was up here, but anyway. So we have Burrow. Then Burrow is from a small company called Monax, and Casey is supposed to present Burrow next. I don't know whether he's going to show up. The other DLTs are Iroha, which is represented by Alice, who's going to speak. So in that sense, we are a totally different kind of consortium, right? There's 250 or so members, big companies, small companies, and it is totally open source. Plus, it is not a membership-driven organization. That means you don't have to be a member to participate. I'm not a member of Hyperledger. I don't pay them, yearly fee, but I do work in the community, and I was involved right from the beginning, meaning right from 2015, when we first had our first hackathon, trying to connect two different blockchain platforms together, the front end of DAH and the back end of, at that time it was called Open Blockchain, but it was IBM's, what eventually became IBM Fabric. So all that to introduce the whole concept of Hyperledger itself. Now let's see where I come from. I am a capital markets developer for 20 years, but before that I did work in media development, as a programmer, and I consider myself right now an independent blockchain worker, which may be a strange term to most of you, because it encompasses not only development but also community work. And I'm not a cryptographer nor a crypto engineer, but in the 90s, I worked on some crypto for Audible. So in a sense, I'm a crypto engineer, but that is using technology that was, DES, which has since been superseded by AES from NIST, from NIST. And I am a proposer of URSA, which means that I am one of the community people who said, this is a great idea, let's move it forward, let's put it into the labs, which is another place where you can incubate code and then move it into its own full project. And the last thing I put there is I'm a poet. Why do I say that? And why is that important, right? Because there's this thing which says code is poetry. Why is code poetry? Because in succinct language, it expresses something that is greater than just the words that you see there. And that's been my experience with writing programs. It's always expands, emerges, the effects emerge. And sometimes it's good effects, sometimes it's bad effects, right? So that is the main reason why we proposed URSA, because too many people in the community are rolling their own crypto, which is a very, very bad thing. So I want to thank, I start with the thanks to the community, to the completely open ecosystem, to the maintainers and collaborators. And this is, of course, a call to all of you to join the effort and become contributors and collaborators. And it's not just code. So the motivations behind URSA: we want to avoid duplication. That means since there are all these different different DLTs, they shouldn't all be writing their own crypto implementations. And the security is easier to analyze the crypto portion of all of these DLTs if it uses a common library. So there were 3 types of people who take part in URSA. One is the cryptographers, the actual guys from Dfinity, from various other open source proponents who are actually the people who write the papers, who write the thing behind the actual implementation. Then you have the engineers, and then you have the cryptanalysts. So we have all 3 types of people coming together here. And you know that there would be a review of the code, which increases the security. And cross-platform interoperability, which means not just among the DLTs that are out there, but also cross-platform in the sense that it works on Mac OS, on Linux, on Windows, on other operating systems, and on the mobile devices, iOS, and so on. And if you look at Iroha, which Alice is going to talk about, it's concentrated mostly on the mobile devices. And this is a modularity play also, because you can mix and match the different things. And access to URSA makes the new projects easier to get off the ground. So I have listed here several things about the language support that we offer. First of all, it's written in Rust, which is a very interesting language. I suggest you try it out, because I'm an old C++ and C programmer, but I know the dangers that lurk in the system because of memory access, typing, void pointers, all kinds of stuff that you control the memory, but you don't release it. So Rust is got some powerful features that make that programming much safer. So the foreign function interface to C. So URSA is a wrapper around existing libraries that are widely used. So we're not writing new crypto libraries. What we are doing is simplifying it so that the construction of a library that does crypto can be through this interface, this thin interface that we created. And Rust is ideal for that, because you can do compile time protection as well as runtime protection using configurations, so that you do not have unexpected stuff lurking around in your code. So the wrappers, as you know, it is the outward interface. Python, which is used in Burrow, Golang, which is Fabric, Java, and other languages. And I already mentioned the thing that it's written in Rust. And we have two libraries. One is a simple lib-ursa, and the other is the one that contains the zero-knowledge ZMix libraries. And those three libraries at the bottom are the ones that we are creating a layer over, which is lib-sodium, SecP 251, 256K1, and OpenSSL. I went over some of these things, but here I want to point out a couple of things. The things that I would point out is that the AES is now a NIST standard. SM4, or the SM family, is the Chinese crypto. And Kuzniechik is the hash function used by the Russian family. So if you want to do business in Russia and you want your digital signatures to be recognized there, you have to use that. Same with China in the sense that you have to use a different set of libraries, different set of functions, families. I don't know whether I'm going into the details of any of these, but I'm not. I'm just going to talk about the fact that a signature function to be used is very simple, right? I mean, there are only three functions that you need. Basically, you need a key generation function that generates a private and public key pair, and then you need, or if it's a symmetric key, then you need a function to generate just that symmetric key. The other is the signing function, and the third is the verify function. So the simplest URSA interface would consist only of those three functions. But underneath, it wraps the complexity of all of those libraries, which you can constitute by compile time switches. You can say, I am building this for the US government, so it has to be FIPS compatible. So what does that mean? It means it uses AES, it uses Ketchuk, and it uses standard signature functions. And the last one is about key exchanges, and we don't need to go into the details of all this, but the basic idea is that you're able to control with a simple set of switches what it pulls in, and then you are targeted for a specific sovereign, like the US government or the US-based digital signature schemes, or the Chinese-based digital signature schemes, or the Russian-based schemes. Of course, we would expand this to other countries, other standards, so that we are usable in all over the world. I also already mentioned most of these things. One of the most important things is the one at the end, which says AES plus SM is not allowed. Why is that? Because SM, which is a Chinese standard, is assumed to be backdoored. So you don't want the NIST-compatible AES algorithm and the SM to be mixed together in your implementation. You either choose one path or the other. So we have the two types of interfaces. Like I said before, one is a simple one, which I mentioned would just be done with three functions. And the crypto developer interface would be much more complicated, and it would be not visible to the outside, but more for the developers themselves. And this is the other part, which is the zero knowledge part, which is not as well developed as the regular lib-ursa. So most of this code has been actually written and used by Indie, by Sawtooth, by other, by other DLTs that are already developed. So they contributed that code back, and the knowledge and the community. So this is the current status. So you can go through the list and see that some of the things are working, some of the things are not, and we need contributors. Basically, that is the whole idea, that we need people who are knowledgeable in Chinese SM, or for doing the foreign function interface from Rust to C to be auto-generated. Some of the most important work is the last three bullets, which is the CI/CD pipeline, which is the continuous development and continuous integration pipelines, which do tests automatically, making the library robust and safe to use. Documentation, and also feedback from people who use those libraries. And we have the URSA meets bi-weekly, and it's completely open to all. And there's a chat channel, homepage, code, RFCs, documents. All this is completely open, available to everyone. That is the beauty of open source in Hyperledger. I'm going to pause here for any questions that you might have. Okay, that means I get 2 minutes and 58 seconds of time back. And yeah, and there's Silona with the Hyperledger hats, which are swag. If you want those hats, please contact her. Any other questions? You can also talk to me later. All right. Okay then.